one more thing. Oh, I just what was the 11011111, right? That was our. So it is 8 bit. 8 is not a. Can you just take a bigger one? Say we have just added 1100. So 16 I have taken. Now what they are doing 1101 1111 1010 1100. So they just make a 4 cross 4 matrix. If it is a 16 bit of data, they just create 4 cross 4 matrix. Yeah, actually it's not 4 cross 4, but I think it is 16 byte. 16 byte of data. They take 4 by yes, actually 4 by 8 by 1. Sorry? 8 by 1. No, because 8 is not a square number. 4 square root of 16 is 4, right? But square root of 8 is better. So square root of 16 is 4. That's why 16 bit is taken. So that we can arrange it as a matrix format. Now it is not only splitting into 2. We are actually creating a matrix. Now they are going to from 2D to 3D. Now like from 1 dimension to 2 dimensions we are going there. Right? There. So this is the 1-dimensional vector array. Now they have created this. Then they do all the circles on this matrix. Matrix addition, matrix multiplication, matrix dot product, all these things they do. Okay. So I am showing you a demo. Open a new window. Just quickly showing this one. What is happening? Stop reading. Okay, you can see it, right? What are you saying? Share desktop. What is coming? Oh. That's correct. So this is a plain text. There is a key, and the ciphertext will come. This is the black box. Simple. What is happening? What the magic is happening inside this box? As I said, these are the. They start with this thing, and the cipher the different. This is the block from the plain text. The plain text is rearranged as a key, 4x4 matrix, and it creates another matrix which is the cipher key. Now for all these blocks, all these different position, the matrix member, so these will be transposed to something else. This will be substituted to something. So there are two things we'll focus here. One is how the encryption process works, and secondly how the key scheduling is work. That means we are not going to use the same key, the same thing that arrangement and all, but even for one single cipher also we are not going to use the same key. For inside the cipher also we will create different keys in every iteration. So let us start with the encryption process. I have not made this animation. I just got it from somewhere. Okay. So I do not know who has made it. Otherwise, I should have a card to him. Okay, so this is where we are starting encryption process. It is actually creating these four sub process. It goes every time we are taking 16 chunks, 16 bytes of data from the input. Then we do the sub byte, shift rows, mix columns, add rounds. So this is kind of a substitution of your SP network, you can think. Same SP network, but now we are not doing just in linear thing. We are actually making it in a matrix format, and then with the matrix we are doing the same circus. We are doing the same diffusion and confusion here using two-dimensional space. Okay, so now what are these things? Sub bytes. So this happens for 16 rounds total. The last round it will just pass from here. Oh, sorry, 10 rounds. For AES, there are 10 rounds. 9 rounds here and 1 round after that. So all these things happens 10 rounds. Now let's see what is sub byte. It is very much similar to our Wigner cipher. This is a fixed S box. This is a fixed S box. This is a table. They just take 1 9. 1 9. It will take this. So it will be replaced like this. Perfect. Then the second operation, shift rows. This is one time shift. This is two shift. This is three shift. Okay. Shift rows is done. Then mix columns. Take one, then multiply with this matrix and create one. The third one, the fourth one, add round key. So this is the first, or like from the round keys, the first round it is provided, second round it will be generated. How it is generated? Take this one, exert, this one will be here. Now what will be the next round key? Again this one will be as a next round key. This one. It will keep on changing. The defined steps I'm not going. I have not checked whether everything is fine, but it should be. Right? So this is the ciphertext. This P box and S box is happening now. Every time how the key scheduling, that is this step for where how we are getting this one. This is the question. How we will get the round key? So now I'm coming to that. First, this is a fixed matrix we will start with. Sorry, this is the fixed matrix we will start with. Then take this one, sub bytes, do the same thing. Now you will add this one. This is the first one. Second, we are creating the second round key actually. Exert. Now this has become our first round key. This is the cipher key. That is this is fixed one. This is first one. That means what we do? This one. Then we just rotate this one to here. Then again we use that substitute S box. Then we replace them. Then we take the first column, like just 3 columns I have before that. We just exert, and we'll put it here. Simple. So this is the first column. For the next column, it is only one time exert. We'll not do the substitution and all. Fine. This is how we are creating the second round key. Got it? That means 10 rounds are there. 10 round key will be created. Fine. So now it seems a doable job, right? It is not doing some magic. It's doing something. The same S box P box substitution, but it is using something more sophisticated matrix mathematics, like more better algebra it is using. That's all. Fine. And it is like super fast also. Like here we see now in the computer level, everything like every clock cycle it will perform one operation, it is done. So all these different operation it will be done in one clock cycle. Done. Simple. Okay. So now AES is fine. We know how AES works. Is there anything else? No. AES we have just covered. So now there are other crypto systems like Blowfish or Twofish, which is used by Bruce Nair. This guy is Bruce Nair. He's still there. In fact, if you go to any Black Hat conference or RSA conference, these guys will be there. This guy was once I had a chance to work with this guy. His name is Ron Rivest. So Ron Rivest is for this RSA crypto system. We know RSA cryptography, which is asymmetric cryptography. So RSA is that R. Rivest, Shamil, and Adrian. And all of these three were my senior director to my team once upon a time. So these guys, this is the RSA is also a company made by these three companies. They are the founder. Then later EMC bought that company, and these three became three senior directors to that company. So I had a chance to work with Ron once upon a time. But like I am very excited. He might not be knowing or remembering me. That's fine. Yeah, that is a fair thing. But yeah, this is the guy who is our training leader, RSA. And he came up with a, like, he also participated in the same competition, and he came RC5 and RC6. So if you want a comparison between different crypto systems, there is a very nice way. What is hovering? Oh my god. Okay, I will have to find something else then. Most of them are yes. After a certain point of time, there is no difference between a mathematician and a computer scientist. Even if when you are doing PhD in computer science, it is nothing but doing mathematics, nothing else. It's nothing implementation, or it's not an engineer's job. When you are doing a PhD in computer science, it's mathematics only. Now, okay, break we have already taken before, but I'm giving you another problem. So far, in symmetric cryptography is fine, perfect. The only problem here about this symmetric cryptography. Now, how about a multi-party communication? For even two-party communication, I have to share the key. Come on, I have to share a small piece of information, and that is a secret. If I can achieve that, if I can achieve that communication channel, then I can send the entire data. What's the big deal there? Now there is somebody named, like, two guys, Diffie and Hellman. There are two guys, Diffie and Hellman. These two guys came up with a beautiful idea. So they did not come up with new cipher. They did not do any encryption algorithm. They did not do any decryption algorithm. Nothing. They have given a nice solution to this problem. How I can share my key, or maybe I am communicating with it. Maybe all of you are here. All the communication you can hear. You can overhear all our communication. Still, at the end of the day, me and Abhijit will have a shared secret that you guys cannot understand. Is it possible? Just get the problem. Every single piece of information we are sharing, like me and Abhijit is talking, you guys are overhearing. You can hear everything that we are speaking. You are not missing anything. But still, at the end of the day, Abhijit and I will have a secret that you guys will not understand. How? How? There is nothing. It's just open communication. And secondly, you and me had not had a chance to talk before that. Okay, this is the signal. This is the. Terminology. Huh? All terminology. No. As I said, we have not had a chance to discuss that. Hey guys, this is how we will communicate. This is the code word. Nothing like that. Just plain and simple communication we are doing. You only know something, I only know something. In fact, everybody knows that how it is working. Everybody knows what we are communicating. Every single word we are communicating, but still at the end of the day, at the end of the communication, you and me will have a secret that none of them will understand. They all know how it is happening, how exactly you are creating your secret, I am creating my secret, all of them know. Everything I am sending to you, they know. Everything you send to me, they know. But still, we two will have a common secret. They will not have it. Is it possible? First of all, is it possible?
Not possible. No? We need to communicate in encryption. We only
The, how the key how that is the question. How we can share that? So this is DP-Hellman is used.
the DP Hellman is using a mathematical formula.
Whatever he is using, but is it apparent to you? I am going to mathematics later. Now first just think that two guys thought okay this can be done.
Possible.
How?
With DP Hellman.
Yeah, but DP-Hellman is a solution. What is the problem? And now, are we good to solve that problem? If I was born before DP-Hellman, can I solve the problem? Is that the question? That is the question. Like if you are born before DP-Hellman and if you are given the same problem, can you solve it? Probably all of us can, because just think whatever we have learned so far, like, at least we could approach to the problem. Maybe we just immediately we are answering, but if we are given some time, probably we could come up with the same thing, with the same level of education and same thing. It is not a rocket science, right? Everything we could connect. We could connect because we know probably we would do the same thing, right? Here, at least, can you imagine that this is a doable job? At least somebody thought this is a doable job. This can be done. So do we understand this can be done, or is it still a surprising thing? You understand? Every piece of communication, you know how we are creating the secret in our. Still, you guys will not understand. Let's see how it happens. Interesting. Tell me how.
So what I remember is both of them will be assigned a prime number, and maybe it is a mod function or read function, but the output would be same. We will also get 2, 3, 4, 5, and he will also get 2, 3, 4, 5.
But how other guys will not understand? They will also get the same thing, right? How? That is, you know the solution before. I just want to forget you everything, and I want to just start afresh that how it is possible. Is there any? Mm-hmm.
Now, there are two prime numbers, both will same, and after mathematical operation, the answer remains the same.
Okay. 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 Let's before hash. I'm just finishing this one. I initially thought that I will finish the hash, then come back to this. So this is an interesting problem. It seems, right? Let's see. We will do something.
Is also group, right?
Let's see. Let's see. Let's see. Let's let's forget mathematics, prime number, everything. Let's just forget everything.
So
Just
both
a
has to be on the same group. You need to agree that we communicate for group 2, group 3, 50, 50.
let's see. Just forget about numbers, forget mathematics, forget development, everything. Prime number, nothing. We'll do something very simple thing. First, I am telling you take a color. Okay. Uh, Click it. Okay. First, I am asking you to take a color. Say, and everybody will know the color. That color everybody else will know. Say I have taken yellow color. Fine. So this is me. This is Shomo, Vijit. This is rest of the folk. Sorry, Eve. Okay. So now I know yellow color. I'm openly telling you I am taking a color called yellow. Okay. You also know this is yellow. all of the other folks know it is yellow. Guys who are online, you are following me?
Yes, sir.
Okay. So now we have all know there is a color. Okay. Now I am asking, like I am taking a secret color that nobody else will know. I am not telling it to Avijit also. I am just taking a secret color. Say maybe this one. I am just taking a secret color. This is my secret color. You guys don't know. Avijit doesn't know. And I asked Avijit, you also select a secret color, but you don't need to tell me. So he just took another color maybe. So these two color, I know this my color. Avijit knows his color. This color everybody knows, and you guys do not know any of these colors, right? What I will do, I will simply add these two color, mix this color. It will create a new color, right? Let's do that. What? Mixing? No, everybody knows what I am going to do. You know the algorithm. You know what I am going to do. I'm just mixing. I have, but what you do not know, this is secret.
Color we don't know. What you have mixed in yellow, that we don't know.
Yes, yes. What I mixed with, yes, what I mixed with yellow, you do not know.
Maybe after one formula, we get the purple color, get the blue.
No, coming to that. So my color is this one, right? So I'm just adding this color. It will create a new color. And Avijit is creating a new color. He just added this one. Okay. Now my new color, the after addition, whatever color I get, something red, whatever, I send that to Avijit. All of you know I got this color. So you guys know there is a
We'll see red and green.
red. Yes, red green is very like how much red? What is the hex value of that red, or what is the exact shade? That is understanding that is a little difficult, right? Like red is a very simple term. We all know, but what exactly two? So the here point is mixing two color and creating new color is easy. But from that new color, you can never get back what are the colors mixed in what ratio. Got my point? So whenever we are painting, we know to mix two colors. But when we have the mixed color, we can never split out what are the colors that has been mixed. You can never do that. This is a one-way function. Got my point? You connect it, right? If I give you a color, you really cannot tell me which two colors I have mixed. And you all guys know this one. Draw. Because we have communicated. Fine. Now what I will do, I will just send this one. I will simply send this one to Avijit, and Avijit will send this one to me. So what I will have draw again. I have mixture of this color and I have a mixture of, so sorry, I got this one as well, right? I have this one and I have this one. What is my secret color? This one. I just add them here. Sorry. Draw. So this is the color I got from Avijit. On this color, I will add my purple color. So what is this? What is this blackish color? What is this? This is yellow plus my secret color plus Avijit's secret color, because this is this is yellow plus red, and this is okay. Just which is this one plus this one plus this one, right? I got this color from Abhijit. This color is nothing but yellow plus Abhijit's secret color. I mix my color. I will get a new color. You guys know this color. This green color you know. But you do not know my secret color. You cannot come up. Can you come up with this color? No. What Abhijit will do? Abhijit will do the same thing. So I will say I sent him yellow. Yes, plus purple is the red one. So that means this is actually these two. This is this, and he mixes his own color there, which is blue. So now I have mixed these three colors. Abhijit has mixed three colors. We will get the same color because same ratio, same color we have mixed. What you guys will do? You guys have this color and this color. If you mix, that means 2 portion of yellow, 1 portion of purple, 1 portion of turkish. Here I have 1 portion, 1:1:1. Here, even if you mix these two, this is 2:1:1, right? The ratio is the yellow will be more if you mix these two things. So you will never come up with this idea, this color, because we know my secret, he knows my secret. We can actually mix three colors, but you got two color mix, but since you do not know the secret, you can never come up with the same color. But we two have the same color. Clear? Connecting? No prime number, nothing. It's very as simple as that. Somebody thought this one.
Then we got converted into math.
That has, but at least the basic thing. This is the basic thing. Probably this color thing will not understand. So what is the property it has? Color has everything. Yes. Anybody saying anything? Okay. The color has a very nice property. If you mix two colors, it's easy to mix, but it's not possible to split to tell what are the colors mixed. So that is called a one-way function or the trapdoor function. Why trapdoor? This is a trapdoor. It's uh, it's easy to close. Like there are locks, trapdoor locks, you know, right? It's easy to close. Once the lid is locked, you need a key to open. Right? It's a trapdoor. This is a trapdoor. It's easy one way. You can open it one way. If you know it is only pull, you cannot push. One way function. The door opens in only one side. If somebody pushes from that side, it's very easy for him to get in. If somebody wants to go out, they have to pull. We human know, but just think about an animal. Animal can enter in this house but cannot go outside. They do not have hands, they cannot pull that. Right?
So for this, again, both the parties will exchange the hash function to check if they.
What is the hash function? I have not come to hash yet.
No, to check if their keys are valid or not.
What is the keys?
You are not sharing the keys.
I am not sharing anything. We know, now we know that we have the same color. Everybody is hearing everything, everybody knows all the colors, what is exchanged, but they will not come. Now we can replace it with numbers, of course. So this is a trapdoor function. Mixing two color is a trapdoor function. The door, that is, as I said, it's easy to get into. Animal can get into, but cannot go out. That is a very trapdoor is used for the rat. It is actually a what is called rat cage. Rat can go inside but cannot come outside. It is very much similar to that. It's one way it is easy. The inverse is not almost not possible. So let us start with a key also, like with a number. You guys understand who are online? You guys understand what we just discussed here? Now what we will do, we have
We have taken a number, any number, just any number we have taken. 2. You guys also know 2. I have a secret number. Abhijit has a secret number. What I will do? 2 power 4 equals to whatever is 16. I will send this 16 to Abhijit, and Abhijit has a secret number. He will just make 2 power 5 equals to 32. He will send me 32. So he has 16 now. I have 32 now. Now just imagine, this is also a trapdoor function, that finding a power is easy, but square root is not. Like, you can easily find 2 power 5, but square root of 32 is difficult. We know this one, that's why we have a log table or we memorize this thing, but we never find that what is the fifth square root of 32. We do not know any known formula for that, right? We do not know that. So this is a kind of a trapdoor function. With a small number, we memorize, okay, 2 power 5 is 32 means fifth square root of 32 will be 2. But we just know, but we cannot calculate. If it is a very big number and if I ask you to find the fifth square root, it is not possible. So this is a trapdoor function. So from this 32, even though you know 2, you will not find 4. For this 32, you cannot find 5. You need a log table for that. It is a small number you can easily find, but otherwise you need a log table. You just think a situation you do not have a log table, then you cannot find it. You do not have a calculator or a log table. Or here also you cannot find. From 16 you cannot find the 4. Fine. Now what I will do? I will just simply make 32 power my number. Okay. And Abhijit will, 32, yeah, I got 32. And 16 power his number. They are same number, right? Got it? So these two are same number. How it is possible? Because this 32 is nothing but 2 power 4. This is, 2 power 5. This 32 was 2 power 5 power 4. That means, 2 power, not 9. Yeah, 2 power 9. You're right. 2 power 20. No? 2 power 20. Okay. And here also it is 2 power 4 power 5 equals to 2 power. Okay. That's how it is coming. So that's why at the end of the day, we will end up with the same number. But you guys, even though know 32, you know 16, you know 2, but you just do not know these two numbers, you will never get the number. Simple. It's not complex, right? No prime number, nothing so far. So far, yeah. We'll slowly go to the exact what DPL man has said, but
So here key would be the
yeah, this one. This is the shared secret. This is the key. This is the key. Now we know the key. Now we can simply communicate with ourselves. At least using the key. First time we can communicate the key. Okay, now this is the key. Rest of the thing, all the symmetry. He has a key. I have a key. Fine. We can just, because you guys never will understand the key. Okay. This is still used in HTTPS. Yes, this is still used. SSL certificate of like forward secrecy. It is used in HTTPS. Still used. That is how the first client and server handshaking happens. This is DPL man. Exactly. They will agree. Exactly. So anywhere this problem comes, I want to share a secret from through a through a insecure channel, unsecured channel. DPL man comes into the picture. So this is not algorithm. This is not a cipher. This is a very smart solution of a very genuine problem. I think rest of your life you will not forget what DPL algorithm is, right? Fine?
Encryption will happen for AES.
This is for key sharing. It is for the key sharing.
For authenticity, they will like
And the beauty, like what I really appreciate, somebody thought that this can be doable. Somebody thought, okay, I can solve this problem. This is apparently a impossible problem. Everybody probably thought it is not possible. How it is possible? But somebody thought, okay, I can make it possible. And such a very simple solution, right? This is the beauty of it. Now let us come to the actual ones and all. But if we can remember till this, then also it's fine, because the actual one today we will learn again, we will forget that modulo calculation, everything. Now we have to come. Okay, that's why I actually was doing the hash function before, because after that the actual Diffie-Hellman, if we want to understand, we need to understand little bit of more mathematics about the modular arithmetic. So we don't have the time for that. We have 15-16 minutes and just starting the hash. And the actual Diffie-Hellman algorithm we will discuss in the next day. Okay. After we finish that, some more mathematics on the modular calculus, because that is required for Diffie-Hellman as well as that is required for the RSA. Everything is dependent on that modular calculus. Then the prime number, the modulo, how exactly it was there. So simple idea with the color, with a very small number, with a very simple mathematical function I have shown. The similar one, they have just made it much more complex using modular arithmetic. That's all. There is no other differences. So probably modulo and everything we will forget someday, but at least the idea should be there. Fine. Who remembers there is something called hashing in data structure? No? In your BTech days, when you have had a data structure course, there was something called hash. Who remembers that? Okay, it was there. Like I think people usually study for sorting, searching, string, array. Then there are a lot of other chapters like union, structure, then the hash, then AVL tree, lot of different trees, sparse matrix. These were there in that book, but people used to skip that. But yes, there was a hashing was actually a data structure. What is that? It's very simple, just indexing. Like if I know dog where it might go, I have an index for that. From that index, I will find that data. So it is very fast searching, nothing else. I will apply some formula by which I would know that where exactly that data might exist. If it exists, fine. If it doesn't exist, it is not. Otherwise, if it is an array, I have to search for all the array location. Here, hashing is much more faster for searching because I know exactly where it would be. If I find in this location, it is there. Otherwise, it will not be there. Simple. This is called hashing. So this is how we used to implement the hashing, if you remember. Okay, now we are coming to cryptographic hash. So this hash you will find it like if you remember the data structure, there was also like there are a lot of libraries on hash in Python, in C, but those are not cryptographic hash. Don't get confused with the cryptographic hash. Idea is same, very much similar, but cryptographic hash is much more than that. You cannot simply use a data structure to implement a cryptographic hash. You need something more. And this is for data integrity, not confidentiality. So what is the things from our cipher we can drop? If it is integrity, I don't want confidentiality. I don't want to make it secret. So what are the things from my crypto system I can drop? The key. The key is the only secret. The secret I don't need. I can just drop the key. Simple. Rest of the things will be the same. We don't need encryption and decryption algorithm. We just need one hash algorithm. So this will be like this. If I say it is hash, it will be a plain text. We don't need a ciphertext, but we need actually ciphertext. I don't need a ciphertext, but I need a hash value. It is again A to Z, whatever. Actually, here it is 0, 1, star. This is also 0, 1, star. K I don't need. E I don't need, but instead of E I will say it is a hash algorithm. This is also inverse, right? So it is a keyless algorithm because I don't need any secret. So why should I keep the key? Key is the only secret. I just drop that part. Simple. So if I am saying so, like where we usually use hash. Okay, just a very simple example. Alice picks a random number. She just says my number is odd or even. The question is, can Bob guess the number? No, right? Why? Why?
Very quickly, you can either guess one thing or the other. It's not certain.
So from this information, odd or even, I really cannot guess the number because there are thousands of different possibilities. In fact, countless different possibilities. I really cannot guess the number. The number can be anything. But odd and even actually a mathematical function. Some mathematical function will give you whether this is odd or even. So that means there are not all functions does not have an inverse function exist. So this is a function, right? Odd or even. But you cannot make the inverse function. You cannot, from this result, you cannot find this. But there are a lot of functions that has inverse, like say square. It's very easy. Some function, say square. X. What is happening? Why I'm picking this one every time? Keep repeating. Oh, say x square is the function. Function on x equals to x square. In that case, it's very if inverse exists. If inverse is nothing but root square root of x square or square root of y. Y equals to x square is the function and square root of y is the inverse function. It's easy to find, right? Maybe 2x. If it is 2x, it's very simple to find it will be y by 2. Now tell me one thing. Now this question is for Kiran. Can you find x? Can you find x?
So until unless you know what is the value of x. Whether it's 0.
I know the value of y. Say I am taking value of y is 0.5. From that, can you find the x?
Yeah, we can.
Okay.
I mean,
There are 1,000 different possibilities. Remember? Actually, sine 30, right? Sine 30 is 0.5. So it is not only 30, 30, 120, then again it will come here 180 plus 30, then 180 plus 60. So 1,000 different, like there are infinite possibilities. So sine inverse x, sine inverse y will have 1,000 different possibilities. So is it a hash function? You said that sine trigonometry will not be used in here. Is it a hash function? This is a hash function. No, I'm calling it. What is a hash function? Okay. Hash function is a one-way function. That means we can apply that. We can get the y, but from y I can never get x. Odd or even is a very good one. That one is sin x is also a good one. We cannot find. Right? So, like if it is like this, picks a random x, it says the function of x, it might be like odd and even. I just given an example. So Alice will send a function like, wow, what is the apply a function on x and send that number to Bob. Bob will guess the x and Alice will, if Bob can rightly guess, Bob will win, otherwise Alice will win. So the idea is how Alice can come up with a very beautiful, nice formula or nice function by which Bob can never guess. Odd and even is one, sine is one, and these functions we are calling a hash function. So clear? Perfect. where I am using it. Okay. To releases. How many of you have used torrent anytime? Downloaded anything from torrent? Never in your life. Sorry? I think not for us. Okay. But have you ever seen that there is something written for MD5, SHA, all these things are written?
Not that much.
Yes, yes, yes. The similar question.
Whenever you are downloading from the torrent, it shows that MD5 has SHA has 5. What is the meaning for that? Why?
Integrity. If somebody
But how you can make the check the integrity? Here, if I go to Windows download Ubuntu download page, for every download there is actually a MD5 sums. You see, this is the MD5 hash for this. Many download anywhere you are downloading something, it says this is the hash. But why? The reason being, here is a short one. What is UBEXC? I think. Okay, this is a 2.4 MB file. I just downloaded save link as in the downloads, fine. And also I am downloading this one. MD5 sums. Save links as. So the idea is, I am downloading it right now. I am downloading it from the official Ubuntu server. But it might be possible I might get this exe file from somewhere else. It might be some of you have given me in a pen drive, or I have used the torrent to download it, or I can get it anywhere else, or any third-party repository also. Possible, right? Any third-party repository I can use. I think there is file repos there, blah blah blah. Lot of different soft, Sony, all these different third-party websites which actually have lot of advertisements and all. So those I can download it from anywhere. But how can I ensure that this is the same exe file that Ubuntu has published? One way is I can download the official one from official site and then I can just compare. But that doesn't make any sense, right? Especially this is 2.4. If I am just downloading the ISO file which is some 3 GB or 4 GB.
So usually what happens is the website itself provides the hash value. So once we download from either from official website or third-party website, we can actually directly check the hash value if it's same hash value or not.
But why hash? Like what is hash first of all? Why and why we are comparing the hash? What is the speciality of hash that we can compare only the hash that's enough hash value? What is it? Why we are doing it? Why? How
source code is tampered, then hash value will get changed.
Okay. So let us take a simpler hash value odd and even.
So hash value is
Just one bit hash function. So the entire few gigabytes of file, if it is odd and somewhere it is written it is odd, I'm good. Or if it is written even, then if somebody tampers, probably it will change. But it's not a very good hash function. That's where we come to good hash function and bad hash function. It is not good because it is very easy to tamper. You just instead the last last bit, you can change any of the bit. It will work. But sign is a better hash. sign on x is whatever big number it is, you can apply sign on that. You will get a value from -1 to +1. And hash function, so you understand what hash function is. So what I am telling, I have two ways to compare to check whether my file is right or not. One, I can download the entire file once again and then compare with them. This has two problems. If I am downloading it from the official site, then what's the point of comparing, getting it from others? And secondly, if I have gigabytes of data, comparing these two files will take a lot of time. So I have to have something. So people thought, okay, we'll do some check, some one-way function. Why one-way function? Because if I can find out the x, then I can create, if I can reverse the function. That means what I am saying, if I can find the function inverse, then I can tamper the original data in such a way that it will create the same hash. Right? Like odd and even. Even though there I cannot get the actual x, but still I can do the value. I can create the same hash, just a 1 bit hash. But if this exists, if I know from y to x I can get, that means I can create, I can manipulate the data in such a way that I will create a different hash. That is not possible. That's not what I want. Okay. So we will have a function. Some function will apply on the entire gigabyte of data. This will provide me some digest or checksum. So what would be the properties of that function? You guys tell me now. What are the properties that function should have? Sorry. Tell me. Okay, I'm studying.
One way.
First of all, yes, one way. Good. Second,
The reverse function should not be.
that is one way. Second, how about getting a hash value which is equal to that plain text? Like if I apply the hash function on 4 GB of data and I am getting the hash value 4 GB, is it a good hash function?
No.
So it will have a fixed length.
Checksum value.
It's a checksum value. So it should have a fixed length. Okay? Third, it should be function should be very fast. Right? Should be very fast. Doesn't matter I am applying it on 4 GB of data, 40 GB of data, or 4000 TB of data. Doesn't matter. It will work. It will work seamlessly and it will be very fast. It should be very fast. Anything else? Anything else?
No to agriculture the same function.
Okay, but is that possible? Because I am telling it will have a fixed length output. So I have say 16 byte of data, 10 text, and I have 4 byte of hash value. That means for every 4 plain text there will be the same hash value. Is not it? I have 16 1 0 1 1 1 0 1 0 1 0 0 1 whatever. And I am telling you, I will always give you an output of 4 bytes, like 4 bits. That means it is not possible. I apply on this one, I will get this one. So how many total value are possible for with the 4 bit? 2 power 4, only 16 value are possible. What will happen now in the 70 plain text? Plain text can be more than that, right? You are getting my point. Say plain text is 32 bits. So there are 2 power 32 possible plain text, but output is 2 power 64 possible output. That means, of course, there will be 2 or 3 or more than that. In fact, in this case, there are 8 different plain text will have the same hash value. Is not it? Got it? Got my point? What I am saying? Because we do not have more values. It has to repeat. So what you are saying, sir, it is not possible. In fact, that is the main reason we are using hash, because we are reducing the size. If you need all possible things, then you have to actually increase the size of the hash, and then only that is possible, or at least keep them same. So this is not possible. In fact, that is something we want, but this thing is called hash collision. But what we want is hash collision cannot be guessed, should not be guessed. It should be totally random. You will not know that which is the next plain text for which it will be the same output. You cannot know. In fact, uh, that is the main technology on which the entire blockchain works. We do not know that when the hash collision will happen. That is the main thing of the this blockchain. Okay. Okay, I'm just quickly showing something here and then we'll stop. So now we know what a hash function is. We'll now go to the mathematical details. Before adjourning, I'm just showing you one quick demo on the hash function. Okay, if I can copy this thing, right? Downloads. Okay, what is the name of the file? There is in Windows there is a utility called sort util. Okay. If I want to create a hash for a function, so I can util, I guess the function name, the file name I have to give. What is the file name? Say yubi. You don't know what it does. Yu. Sorry, this is a util. MD5 sum. Sorry, not sort util. Sort util is different. No, MD5. MD5 sum of W. You see, this will create the sum like MD5 of this file. And what we are doing, cat You see here is one MD5 and this is another MD5. This is how we usually check whether these two are matching. Okay. So if these two matches, that means this file is not tampered. That is a very simple thing, and that's why you will get in your torrent, in the download side, you will find this one. And start util in Windows, this actually will tell you. Oh, I can see here.
MD5 is now deprecated, I think, sir.
MD5 is deprecated, yes.
It has collision.
Has weak collision resistance.
Yes. Star 256 is correct.
We'll come to that. I am not like I'm just showing it with MD5. Yes, I will show that. If you see, it is this sort util actually checks that verifies this MD5 and it says that whether it is fine or not. So the hash file is fine. So this is how you can generate the hash, and I just forgot the command. Will see, so that command will tell you that whether this is good to, like, whether this MD5 hash is matching or not. Options now. What is Unicode, GMT, second silence, split, private key, password? Okay. Yes. Probably they have removed this one. Oh. Okay, -C. So we can search here also. MD5 -C. So it says this one is okay, but rest of the files are not existing, but this one is okay. So this is the utility we usually use to find out whether the hash is matching or not. Okay. Okay, this is, so let us stop it here. So at least we got some idea what is the hash. Next time we'll just go deep into the hash function, not much deep, but yeah, how the MD5 like how we can create a good hash function. These are the properties we know, and few more properties we will just discuss. Okay. There is something called avalanche, like the same confusion diffusion things come here. Okay. And we'll see. Like, we'll cover all these, like we'll check different hash functions, and we'll see that whether all these properties are holding and which one is the case and how we can implement a good hash function. Okay. Now the DPL-man will discuss with the actual DPL-man, as well as before that we will just discuss about some modulo arithmetic once again. Then we'll go to DPL-man, and with the same modulo arithmetic we will also see how RSS cryptography works. Okay. Perfect. So far so good. So, and there is, okay, assignments. Just let me tell you the assignments. Yeah, I will do that. The first assignment already told. Okay. The second assignment, just implement a cipher, block cipher. Whatever we have done here, implement using any coding language you are comfortable with. This is the P box arrangement. This is the S box arrangement. This is how the cipher would look, and this is how the arrangement of the cipher would be. Just codify it with any language you are comfortable with. Perfect. If somebody is not very comfortable with coding, at least create the flowchart or the pseudocode. Okay. At least the flow chart will work. At least what will you do one after one? Fine. This is we discussed all the things here. If you just codify it once again, it will be like super planted in your brain. And yeah, so the output would look like this: my cipher, option, key, input file, output file. So you can create your own format. This is just something I have shared. Like this is a guideline. You can follow this one, or you can use your own flags and all. This is for C I have given. But if you just want to implement using Python or using a web like PHP, any web server, whatever you like, you can do that. Okay. And assignment 4 we'll discuss in the next day. How once we discuss on the PKs, we'll discuss about the assignment 4, how to do that. Okay. Perfect.
Now the assignment two.
Yes. Yeah, I will share. So first day also there is one assignment. Okay. And someday we need to discuss. We need to someday we need to have a 1 hour call so that any problem with the assignment we can discuss. Okay. So you will set up that call?
Yes, sir.
Please.
We'll do in the night, sir. It is okay.
Yes, till 3 o'clock is fine.
Night. It is morning, sir.
Yeah. What?
Do you sleep at 3 a.m. and wake up at
10:30, 11.
Okay, so you work in the different shifts.
Yeah, I stay in India, but stay in a different time zone. Things like it's just my out of my habit. It's not like it's not for my office. No, whenever I wake up, I start my office. It's not there is because I am an individual contributor. I don't depend. I'm not dependent on anybody else. So I can work in my own pace and in my own time. Yes, but I do not take any calls after 9 p.m. I just shut down my office laptop. I don't work.
You work for someone else.
No, I'm not that lucky, but yeah, I usually study, watch Netflix, or read books, anything. Life after 9 o'clock, yeah.
We can share it with
You know, constantly early to bed, early to
and
rise.
share the PPT.
Yeah, later because I have to create some changes. I will make next.
Yeah, yeah, sure.
Start reading some Robin Sharma. So 5 a.m. early to bed, early to rise.
But that I tried many times in my life. It didn't work. I am a night owl and it works like that.
Like that, so you.
Yeah.
So 5 AM Club is the book basically it says that feel better.
And secondly, I have spent a considerable amount of time in Kharagpur campus, IIT Kharagpur campus. So where actually, even if you go to 3 o'clock, people are now. I'm thinking to go to bed. So.
But they wake up late, no?
No, usually what happens, we used to have morning classes, like 7 to 10, all the classes over, and people used to, after 10 o'clock, they used to go and have bath if they want. Most of them don't want. Then, then they fall asleep. Then they wake up, have some lunch, again sleep, blah, blah, blah. And then again the life starts in the evening. That is the typical culture in IIT.
For 7 a.m. class, they are already awake.
Yep. So Kiran, I'm not surprised with your schedule because I know this is how it works. In fact, if you walk in the night of 2:30, 3 o'clock, if you just walk the Scholz Avenue, Scholz Avenue is in the IIT campus. If you have been, the main road actually, artery road. So if you just walk, you will see that like people are walking it like it is like a fair. It's a festival is happening. It like that. And especially if it is just after the semester, every people like it is literally a carnival. You will feel.
Then I'm alien. You are alien.
Yeah, if you go there, you will feel that because all the activity starts after night only. Like you know these TVF guys, right? These Jitendra, Avinav, the TVF. So these guys I know because they were also a night owl. They were with the dramatic club of Vadi Kharagpur, and they used to do all their these practices and all these
You're
things.
the class.
Not classmates. I was in masters. They were in graduation.
Oh.
But yeah, we used to know each other because they used to do a lot of rehearsals that time. So the entire night they used to do the rehearsals and everything.
Do you watch their shows? No?
Yeah, I watched. In fact, Vishyapati Sarkar is my good friend. He used to write.
Okay.
So he still writes. Most of the scripts are written by Vishyapati Sarkar. So who plays that Arnab Goswami's role? That fat black guy. So he's good, really nice. He writes really
So
well.
now I should create assignment to link. What will be the assignment? Movie.
There are three assignments.
Yes, one like all four assignments if you create now only.
Yeah, create all the four. The last assignment will be submitted to. So today is. I'm telling you.
The first assignment is not in that.
Okay. So 11th we'll have another class. 18th we are concluding. By 18th, all the assignments till assignment 3 should be submitted.
Okay.
So for the last assignment, I am just extending one more week. So all the three assignment we are going to submit on 18th.
Assignment will be completed by today.
Okay, fine, whatever. No.
So how will you grade for that assignment too, sir?
How can I grade for that?
How will sir give?
I will check the IMDb rating you have done and you have to review in IMDb. I will check that. Sounds good.
Sure. Because I already watched it.
Okay, then write an IMDb review. Fine. So from that review, I will judge. Okay. Then assignment 3, this one will also be submitted on 18th. These two and the previous one which was given,
Assignment 1. Yeah.
assignment 1 on 18th will be the last day. And the last one, assignment 4, it will be 25th. 25th there will be no class. I will finish everything on 18th, but 25th anyway they can submit. We can keep that window open.
So you send me this and
Okay, MCQ, let us see. If 25th week, if that week we will have the MCQ exam, then we'll extend that submission because you need some time to prepare also, right? So that's why if 25th we have the exam, then we will,
Yes, sir.
usually yes, then second you have to submit the fourth assignment. Fine?
so you share this and PPT.
Yeah, I will try
And
to
text you.
Yeah, please. Okay.
Can you please share the first assignment? By that.
Details I have not written yet. Okay, I will do that.
Because it's already have.
Sir, next week we are having it in campus.
Next week in campus or fully online mode, guys? What do what?
Fully online. But hybrid means, sir.
Yes, that's what I am concerned. Then let us have all the 2 weeks fully online. Fine, everybody. Okay, we'll discuss it in the WhatsApp group then. Okay, I am comfortable coming here and to interact with all of you personally, because in online the problem is that once is not there. It's, I cannot see you, you cannot see me, and it doesn't happen. So, okay. Yeah, let's see.
Online participation will be from my side.
Of course, you can take him for good. You don't need to return him back. Okay, should I stop the team's meeting? Who are online, all of us are good.
Yeah, good. Sir.
Okay, thanks.